Hello children, welcome blast from the past. Here we are discussing past year JEE advanced questions. Today we discuss again one more question for complex numbers. This question is more connected with the question which we have already discussed before. You have to go through the previous question also for understanding this question thoroughly, because rotation and all that we have discussed in the previous question. See, Z1 and Z2 are two distinct complex numbers, and Z is equal to 1 minus T Z1 plus T Z2, but T is a real number lying between 0 and 1. Suppose if T is equal to 1, then this will vanish. Z is Z2. If T is equal to 0, what happens? If T is equal to 0, this vanishes, it becomes Z1. That means if Z and Z1 and Z2 are linearly connected, they will be always lying on a straight line. That's a very important idea. If Z1, Z2 and Z3 are connected, all the 3 points will be lying on a straight line. That you know. But this is Z1. Suppose this is Z1 and this is Z2. And Z is a point satisfying this property. Means Z is a point, see, suppose this is 1 minus, this is T, and this is 1 minus T, and suppose this is T. Suppose this is T. If you use section formula, 1 minus T Z1 plus T Z2 is Z, right? You can use section formula. That is Z can be written as, see, what is T plus 1 minus T? 1. We are using section formula. That means Z is equal to 1 minus T Z1 plus T Z2. That Z will lie on the line joining Z1 and Z2 between Z1 and Z2. That's very important. Z will be a point lying on the line segment Z1 and Z2 between Z1 and Z2. And Z cannot take the value Z1 and Z cannot take the value Z2. That's all. That's all. Now the question is what? Mod Z minus Z1 plus mod Z minus Z2 is equal to mod Z minus Z1 minus Z2. Is that correct? This is mod Z minus Z1, distance between Z1 and Z2. This length plus this length is equal to this length. This is correct. The answer A is correct. Now, argument of Z1, argument of Z minus Z1 minus argument of Z minus Z is equal to argument of Z minus Z2. This means what? What is B? Argument of argument of Z1 is equal to argument of Z2 means argument of Z1 minus argument of Z2 is 0. That is argument of Z minus Z1 minus argument of Z minus Z2. You know argument of Z1 by Z2 is argument of Z1 minus argument of Z2. But you can write argument of Z minus Z1 minus argument of Z minus Z2 is equal to 0. This means argument of Z minus Z1 divided by Z minus Z2 is equal to 0. This means you take Z as a hinge. If you take Z as the hinge, Z minus Z1 means this is Z1, Z minus Z1, this is the angle, Z minus Z1 by Z minus Z2. Suppose this is theta. Z minus Z1, the difference of the complex numbers where the arrow ends. Z1 minus Z by Z2 minus Z argument. This we have discussed in the previous question. You have to go through that. Argument of Z1 minus Z2 minus argument of Z2 minus Z1 is theta. Here theta is 0. That means what? If Z is taken as a hinge, argument of, if you take this hinge, what do you get? What is this angle? 180 degree or pi. If you take this as the hinge, what is the difference of the complex numbers where the arrow ends? It is Z1 minus Z. Argument of Z1 minus Z by argument, what is the arrow starting point? Z2 minus Z is actually not theta, it is pi. Actually it is 0. It is given that it is 0. Therefore the answer is wrong. B is not correct. Actually correct value is argument of Z1 minus Z minus argument of Z2 minus Z is actually pi. Therefore, B is not the correct answer. What about D? Look at D. Argument, if you take, see, Z minus Z1, Z2 minus Z1. What repeats is the hinge, is the rotation. But if you are taking Z, this means the hinge is at Z1. If you are taking Z1 as the hinge, what do you get? Z1 is the hinge. But Z2 minus Z1, Z minus Z1, Z2 minus Z1, Z2 minus Z1, Z minus Z1. What is the angle? Argument of Z2 minus Z1, Z minus Z1. What is the angle? 0 itself. Therefore, this is correct. Z minus Z1 and Z minus Z2 is equal. Now, what is the value of this? Argument of Z minus Z1, the value is 0. That we'll discuss. If you simplify it, what do you get? Z minus Z1 into Z2 minus Z1 bar, right, minus is equal to Z2 minus Z1 into Z minus Z1 bar, right? Z minus Z1 bar. This can be written as Z minus Z1 divided by Z2 minus Z1 is equal to Z minus Z1 divided by Z2 minus Z1 bar. This means the complex number Z minus Z1 by Z2 minus Z1 and its conjugate are the same. If a complex number is equal to its conjugate, what you can say? The complex number will be purely real. But this is purely real. Z minus Z1 by Z2 minus Z1 is purely real. If a complex number is purely real, what you can say? This is purely real. Purely real. If a complex number is purely real, the argument can be either 0 or pi. It will be on the real axis. It can be either 0 or pi. About what is the argument of this? Argument of Z minus Z1 minus argument of Z2 minus Z1 can be either 0 or pi. Argument of Z minus Z1 by Z2 minus Z2 minus Z1 minus Z. Z1 minus Z by Z2 minus Z. The Z minus Z1 by Z2 minus Z1. Z minus Z1, Z2 minus Z1. See? Z minus Z1, Z2 minus Z1. Argument is 0. Right? Above argument is 0, it's purely real, right? But this is also correct. Z minus Z1 by Z2 minus Z1 is purely real means argument of Z2 minus Z1 by Z2 minus Z1. Z minus Z1 by Z2 minus Z1 can be either 0 or pi. What is argument of Z minus Z1? The repetition is Z1, but you take this as a hinge. Z minus Z1, Z2 minus Z1. Argument of Z minus Z1, Z2 minus Z1. It is 0. If the argument is 0, it is purely real. If a complex number is purely real, it can be either 0 or pi. Therefore, this is incorrect. A is correct, B is correct, C is correct, D is correct. This is a very simple question provided you know this rotation, right? Thank you.